So imagine you buy this incredibly expensive, I mean like 100,000-ton Lego set, right?
Okay, that is a very big Lego set.
Right. And you play with it for 20 years, extracting every single ounce of utility out of it.
Yeah, that makes sense.
But then when you're finally done with it, instead of taking it apart piece by piece to, build something entirely new, you just sail it to a beach halfway across the world, run it aground at full speed, and completely abandon it in the mud.
Right, which sounds completely absurd when you put it like
This
that.
sounds insane. But the thing is, that scenario is exactly what is happening to the global shipping fleet right now.
Yeah, it really is. It's the ultimate manifestation of the take, make, dispose economy.
Mm.
And when you consider that over 80% of all global trade happens on the water, the scale of that dispose process is just staggering. I mean, we are talking about the largest moving objects on Earth here.
Okay, let's unpack this because our mission in this deep dive is to explore how this traditionally dirty, heavy metal maritime industry is racing to completely reinvent itself.
Exactly.
We want to see how it transitions from that destructive linear model into a powerhouse of the circular economy. And to do this, we're pulling insights from a really fascinating stack of sources today.
Yeah, we have a great lineup.
We do. We've got a policy proposal from the NGO Shipbreaking Platform, a sweeping academic study on port operations from the ISAR Journal, a comprehensive PhD thesis out of the University of Strathclyde, and some truly visionary architectural designs for the Port of Rotterdam.
And the through line connecting all of these sources is, well, it's a fundamental rewiring of logistics.
Right.
It's about completely changing how the vessels that carry our goods are built, how they're tracked throughout their operational lives, and how their materials are eventually reborn.
So if we're going to look at the global supply chain, we really have to start where these supply chains anchor into the land, the ports.
Right, the physical anchors.
Yeah, and historically, these hubs have been just colossal engines of waste. The numbers presented in that ISAR Journal study, they paint a pretty grim picture.
They really do.
I mean, just in the year 2019, the Port of Los Angeles disposed of 12,000 tons of solid waste.
Wow.
Yeah, and they managed to recycle only 30% of it.
And, that figure only accounts for the visible, everyday garbage. The hidden environmental toll actually lies in infrastructure maintenance.
Like what?
Well, take dredging, for example.
Yeah.
To keep harbors deep enough for modern superfreighters, ports globally have to continuously scrape the ocean floor. That process alone produces roughly 240 million cubic meters of sediment every single year.
Which isn't just harmless sand, right? I mean, it's sediment that has been accumulating decades of industrial runoff.
Precisely. You're pulling up legacy pollutants, heavy metals, petroleum byproducts, and toxic compounds from old anti-fouling paints that used to coat the ship hulls.
Oh, wow.
Yeah. So dealing with that contaminated sludge is an enormous logistical and environmental burden.
But the ISAR study didn't just highlight the problem, thankfully. They investigated the solutions.
Right.
They analyzed 30 different global ports to see what happens on a practical level when a port actually adopts circular economy principles.
And the data they uncovered is highly measurable, which is great. They evaluated these ports on a 0 to 5 scale for circular economy adoption. And the researchers found a direct statistical correlation. For every 1-point increase in a port's circularity score, there was a 5.2% rise in overall waste reduction.
It's huge, but the really compelling metric was the energy savings, wasn't it?
Yeah, exactly. That same 1-point increase correlated with a 3.8 kilowatt hour per ton improvement in energy efficiency.
Which means the physical act of moving a single ton of cargo from a ship to a truck suddenly required significantly less power.
Yes. And the study highlighted some pretty profound regional disparities in who is actually achieving this.
Right, who's leading the pack here?
European ports are currently in the lead, scoring an average of 4.1 out of 5. That high performance is heavily driven by aggressive regulatory frameworks, like the EU's Circular Economy Action Plan.
Okay, and how did other regions compare?
Well, Asian ports, by comparison, averaged a 3.2.
Got it. And the sources give us some incredibly vivid examples of what a high score actually looks like in the real world. Like the Port of Antwerp-Bruges in Belgium.
Oh yeah, their setup is fascinating.
It really is. They're operating on a concept called industrial symbiosis. Instead of treating a factory's byproduct as garbage that just needs to be hauled away, they've physically integrated the infrastructure.
Right, so they connect everything.
Exactly. One facility's exhaust heat or chemical waste stream is piped directly into the neighboring facility to be used as a raw material.
That is just brilliant.
By engineering the port so that these factories literally feed off each other, they are diverting 85% of their industrial waste away from landfills.
Yeah, that physical integration is incredible. But over in Singapore, Tu's port is demonstrating that digital infrastructure is just as critical as the physical pipes.
Right, they're using a lot of AI over there.
They are. They haven't just installed a new computer system, They have deployed thousands of Internet of Things sensors across the actual shipping containers, the yard vehicles, and the autonomous cranes.
So how does that translate into the 20% energy reduction the study mentioned?
It really just comes down to physical optimization. The AI system processes all those sensor inputs to calculate the exact, most energy-efficient path for a crane to move a specific container.
Oh, so it just eliminates wasted movement.
Exactly. It eliminates idle engine time, it prevents trucks from queuing unnecessarily, and it stops cranes from making empty trips across the yard.
Yeah.
That granular level of digital choreography is how they drastically cut their power consumption.
Okay, I understand the mechanics of that, but I have to look at the financial reality here. It's very easy to conceptually say, hey, let's install an AI grid, or let's dig up the port to pipe exhaust to the factory next door. But the ISAR study explicitly points out that 70% of port managers view high upfront capital costs as a massive barrier.
Right.
I mean, transitioning a legacy port has to be breathtakingly expensive.
It is, and that is the ultimate friction point.
Mm.
You really cannot ignore the capital intensity of overhauling a sprawling industrial hub. However, the data strongly suggests that those managers are only looking at one side of the ledger.
How so?
Well, the counterargument is that energy savings and waste reduction build deep, long-term economic resilience.
Because ports are highly exposed to the volatility of global fossil fuel markets.
Exactly. When a port like Tua's lowers its energy dependence by 20%, it insulates itself against price shocks.
Right, that makes total sense.
And furthermore, when a port like Antwerp designs hazardous waste out of its system through industrial symbiosis, it completely eliminates the premium fees associated with toxic disposal. So over a decade, those massive upfront costs amortize into a serious, undeniable competitive advantage.
Okay, so if 70% of port managers are terrified of those upfront costs, someone has to prove that the return on investment actually exists at the most extreme scale.
Yes, someone has to be the test case.
Right, and that burden of proof seems to be falling on Europe's biggest player, which is the Port of Rotterdam.
Rotterdam is the perfect crucible for this. To give you a sense of scale, it handles 470 million tons of freight annually.
That is massive.
It is. But its current layout is entirely optimized for a fossil fuel economy. The port emits 25 million tons of CO2 every year.
Wow.
Yeah, and 70% of those emissions are generated strictly by the energy required to run its own logistics.
Which brings us to the visionary architectural work from the TU Delft Master's students, as detailed in the Portus Online magazine.
Yes, their project was amazing.
They were given a daunting prompt, right? Physically redesign a 100% circular South Holland for the year 2050, and they focused their attention on what they called the port's wastescapes.
Yeah, wastescapes.
Yeah.
That term refers to the immense tracts of industrial land, like massive oil storage terminals and coal yards that will inevitably be abandoned as the global economy phases out fossil fuels.
Right.
The structural problem is that you cannot simply bulldoze an oil terminal and dean residential housing. The soil is often deeply contaminated.
Right. You have to work with the heavy industrial zoning you already have. So the students proposed transforming these wastescapes into cascading waste-to-value hubs. And instead of relying on an endless fleet of diesel trucks, they designed logistics systems that utilize the region's inland waterways to transport recycled materials.
The spatial planning in these designs is just fascinating. They essentially proposed rezoning the entire port to act like a living organism.
Oh, I like that.
They mapped out dense, high-tech eco-parks where industrial clusters share gray water and residual heat.
The part that really grabbed me was the greenhouse integration. Here's where it gets really interesting. It's like playing SimCity in real life.
Yeah.
You don't just bulldoze the old dirty coal plant. You rezone it into a high-tech eco-park that actually feeds the local farms using its own exhaust.
Exactly.
The design shows CO2 being actively captured from these industrial clusters and piped directly into the sprawling greenhouse horticulture farms located on the port's northwestern edge. So the factories are literally feeding the local crops with their carbon exhaust.
It's turning a climate liability into an agricultural asset.
Yeah.
It scales up the industrial symbiosis we saw in Antwerp, from just a few factories to an entire regional economy.
Right.
And importantly, the students didn't just rely on concrete and steel infrastructure.
Right.
Several of the designs actively incorporated ecological infrastructure too.
Like what?
Well, they argued for allowing certain lower elevation, underutilized port areas to revert entirely back into natural wetlands.
Wait, putting a wetland inside one of the busiest shipping ports on Earth seems completely counterintuitive.
It does, right? Until you look at the functional utility of a wetland. Those natural spaces act as a critical physical buffer against rising sea levels, protecting the expensive infrastructure behind them.
Oh, I see.
Yeah, and they also naturally filter and purify the water circulating through the port region. The realization here is that biology can often manage water circularity much cheaper and more efficiently than a billion-dollar treatment plant.
That is so cool. So we can visualize these ports transforming into highly efficient, ecologically integrated hubs. But that only solves half the equation. We have to look at the cargo vessels actually moving between these ports.
This is where a massive paradigm shift needs to happen. We have to stop viewing ships merely as transportation vehicles and start recognizing them as floating, high-grade material banks.
And the projections from the NGO shipbreaking platform highlight why this is so urgent. They estimate that the number of end-of-life vessels is going to multiply fivefold by the year 2033.
Fivefold, that's a huge wave.
Yeah. In the next decade alone, just the ships owned by European Union companies will represent over 136 million tons of what the industry calls light displacement tonnage.
Which, in plain terms, refers to the actual physical weight of the ship's structure. The steel hull, the bulkheads, the heavy machinery, when the vessel is completely empty of fuel and cargo.
Right, it's just the raw material.
Exactly, it's a measurement of the raw material yield.
And according to the report, that 136 million tons of displacement weight translates into a potential yield of 100 million tons of premium, high-quality scrap steel.
And capturing that steel is absolutely vital for the climate. The environmental math heavily favors recycling.
How much of a difference does it really make?
A huge one.
Yeah.
If you look at primary steel production, which requires mining iron ore, transporting it, and melting it in blast furnaces at extreme temperatures, it is incredibly carbon intensive.
Right.
But if you utilize recycled maritime steel, you save 1.5 tons of CO2 for every single ton produced.
Wow, the efficiency gains are enormous. The research shows that recycling that ship steel uses 72% less energy than making it from scratch.
Yep.
And it drops associated air pollution by 86% and water pollution by 76%.
Exactly.
Okay, but the logic here is breaking down for me a bit.
Oh, why is that?
Well, if recycled ship steel is this highly valuable commodity, and it saves shipping and construction companies 72% of their energy costs, why on earth are ship owners sending these multi-million-dollar assets to rot on a beach in South Asia? I mean, it seems like they're literally throwing a fortune away. If I have a mountain of premium steel, I don't abandon it in the mud. The economics must be heavily skewed somewhere.
You've hit on the dark underbelly of global maritime economics there. It's a practice known as outflagging.
Outflagging, okay.
Yeah, and it explains why, even though European Union companies control roughly 35% of the global shipping fleet, only 1% of that fleet is actually recycled within the EU.
Wait, really? 1%? That is an absurdly low capture rate.
It is. It comes down to regulatory loopholes. When a massive cargo ship is nearing the end of its operational life, the owning corporation will often legally change the ship's registration, its flag, to a jurisdiction with notoriously lax environmental and labor regulations.
Oh, I see where this is going.
Yeah. By doing this, they bypass strict European disposal standards.
Yeah.
They then sell the vessel to a specialized cash buyer who sails it to an intertidal beach in South Asia and just drives it onto the sand at full speed.
Where it is dismantled largely by hand in terrible working conditions, while the heavy metals, asbestos, and toxic hull paint bleed directly into the coastal ecosystem.
Yes. It is a calculated race to the bottom.
That's awful.
It really is. Because properly dismantling a 100,000-ton vessel in a sealed European dry dock, safely managing the hazardous materials, and carefully sorting the alloys costs a significant amount of money.
Yeah.
Beaching a ship costs almost nothing.
Right, so it's all about the margins.
Exactly. Therefore, the scrapyards in South Asia can offer the ship owner a slightly higher upfront cash payout for the raw weight of the hull, The ship owner takes the profit and externalizes the environmental cost to the local coastal community.
So if the goal is to stop this race to the bottom and actually secure those 100 million tons of premium steel for the circular economy, how does the industry actually fix this? It seems like we need a radical shift in how a ship is tracked from the very day it slides into the water.
You're exactly right. The primary barrier to safe recycling isn't just the cost, it's a massive information gap.
An information gap.
Yeah. When a modern megaship is built, it comes with incredibly precise material certificates detailing every single alloy, wire, and plate.
Oh.
But by the time that vessel is retired 20 or 30 years later, those documents have almost always been lost or degraded through multiple changes in ownership.
Which completely destroys the asset value of the materials.
Precisely.
I mean, if I'm operating a high-end recycling facility and a 20-year-old ship rolls into my dry dock, I can't just guess what grade of steel is in the hull. If I melt down an unknown alloy and it contaminates a batch of high-tensile steel, I've ruined my product.
Exactly. You've ruined the whole batch.
So I'd have to treat the whole ship as generic low-value scrap.
Right. The uncertainty devalues the material. That is why initiatives like the Circle's Life Project are developing what they call a ship life cycle passport.
Okay, a passport.
Yeah, and it's why NGOs are aggressively lobbying to make these material passports mandatory under the EU eco-design regulation.
So what we're talking about is essentially a Carfax report, but for a mega ship.
That's a great way to put it.
But instead of just telling you if it's been in a fender bender, it tells a construction worker exactly what specific grade of steel the hull plate is made of so they can use it to build a skyscraper without ever having to melt it down.
Yes, and the PhD research from the University of Strathclyde quantified exactly how lucrative this transparency can be.
What did they find?
The researchers developed a specialized digital database specifically for tracking maritime equipment. When they ran a real-world case study applying this database to an end-of-life vessel, the recovery value of the ship's materials increased by over 80%.
An 80% increase. That is a staggering jump in value simply from possessing accurate data.
Data is the foundation of upcycling. The same Strathclyde thesis analyzed the mechanics of remanufacturing.
How so?
Well, if you take a massive high-speed marine engine, strip it down, and rebuild the worn components rather than just tossing the whole block into a melting furnace, that remanufactured engine delivers the exact same operational performance as a brand new unit.
Let me guess, for a fraction of the cost.
Exactly. It costs 50% less to produce.
And we're already seeing pilot projects put this direct upcycling into practice, which is really exciting. The OPCIRC project in Norway is a brilliant example of this.
Oh, I love the OPCIRC project.
Instead of taking ship steel and melting it down in an electric arc furnace, which, still consumes a significant amount of energy, they are physically cutting the steel plates out of the retired ship.
Right.
Then they digitally recertify their structural load-bearing integrity, and they sell them directly into the commercial construction industry.
They're essentially using pieces of a ship as ready-made girders for buildings. It's the absolute highest tier of the circular economy because it requires almost zero additional energy input.
That's incredible.
And we are also seeing this philosophy applied to the interiors of ships. The ReCab project is utilizing the cradle-to-cradle design framework for cruise ship cabins.
Okay, wait, how does that work in practice? I can't picture a reusable cruise cabin.
They engineer the cabin for complete disassembly from day one. They use modular wall panels, snap-in electrical wiring, and easily recoverable textiles. So when the cruise line wants to update the decor in 5 years, the cabin isn't demolished. It's quickly unclipped, and every single component is routed back to the manufacturer for continuous reuse. It eliminates interior waste entirely.
Okay, so the engineering solutions are clearly viable, the databases prove the value, and the direct upcycling architecture is already being tested. But we keep coming back to the economics.
We always do.
Just like the port managers worried about upfront costs, ship owners are going to keep outflagging their vessels to save a few $1 million on disposal. Technology alone won't change behavior without financial incentives.
This is exactly where the policy levers proposed by the NGO shipbreaking platform for the upcoming EU Circular Economy Act become critical.
And just a quick note for everyone listening, we want to be super clear here. We are absolutely not taking any kind of political stance on corporate taxes or shipping subsidies.
Right, absolutely not.
We are just looking objectively at the financial mechanisms being proposed by these NGOs to artificially correct a market that currently rewards environmental damage.
Exactly. The proposals are simply designed to align profitability with sustainability, and one of the primary targets is the tonnage tax regime.
Okay, What is that?
Well, under current laws, shipping companies receive substantial public tax breaks based on the sheer volume of cargo they move. The NGO proposal argues that those financial subsidies must be strictly tied to circularity obligations.
Meaning, a shipping conglomerate only gets their multi-million-dollar tax break if they legally guarantee their ships will be recycled at an EU-approved, environmentally sound dry dock. It leverages a financial carrot, basically.
Yes, exactly. If a company wants to benefit from public tax funds, they have to adhere to the public's environmental standards.
Makes sense.
The second major lever is more of a stick, referred to as a ship recycling return scheme.
Yeah, I found the mechanics of this proposal particularly elegant.
It functions like an environmental escrow account. The proposal suggests that any commercial vessel calling in an EU port, regardless of what country's flag it happens to be flying, would be required to pay a calculated license fee into a centralized fund.
So that return scheme, it's basically a massive deposit system.
Essentially, yes.
Like when you pay an extra 10 cents for a soda can and get it back when you recycle it, but scaled up to a multi-million-dollar, 100,000-ton cargo ship. So every time that ship docks to offload cargo and generate profit, a tiny fraction of that revenue is locked away.
Exactly. And over a 20-year operational lifespan, that fund grows into a dedicated pension, specifically earmarked for the ship's own demolition.
Wow.
It guarantees the capital exists to pay for a clean, safe dismantling process, so the company doesn't have to take a sudden loss when they retire the vessel.
It elegantly internalizes the true cost of doing business because, for decades, the global shipping industry has successfully pushed the hazardous costs of disposal onto the vulnerable coastal communities of South Asia.
Right.
This return scheme forces the industry to build the price of a clean death right into the operational life of the ship.
It really does.
Yeah.
So when we pull all of these complex threads together, what we're witnessing is an industry being forced to completely reimagine its physical footprint. We are seeing a shift from legacy ports that dredge up toxic sludge and generate mountains of unmanaged garbage toward the hyper-efficient industrial symbiosis of Antwerp and the visionary wetland-integrated regional planning of Rotterdam.
And we're moving toward a reality where we stop bleeding 100 million tons of premium steel into the ocean.
Exactly.
By deploying digital material passports, proving the massive financial upside of direct upcycling, and instituting escrow-style policies, we can capture those floating material banks and actually keep them in the economy.
It proves that even the heaviest, dirtiest, most entrenched legacy industries on the planet can be redesigned to operate sustainably, provided the data and the financial incentives are properly aligned.
And why does this matter to you? Because whether you work in corporate logistics, environmental policy, or you're simply a consumer, the global supply chain touches everything. The laptop you're working on, the clothes in your closet, the furniture in your living room, they all likely spent weeks inside the steel belly of one of these leviathans.
They absolutely did.
When the maritime industry shifts from a linear path of destruction to a regenerative circular loop, it fundamentally alters the ecological footprint of every single product we buy.
It really is foundational.
I want to leave you with one final thought to mull over. As this heavy maritime industry perfects the creation of these highly detailed, indestructible digital material passports for commercial megaships, it sets a precedent. Could this extreme level of material traceability eventually scale down to everyday consumer goods?
That's a great question.
Imagine a near future where you can scan a QR code on the back of a broken 10-year-old refrigerator, and a shared database instantly tells a local manufacturer exactly which internal metal components can be snapped directly into the chassis of a new electric car.
Wow.
It means we stop viewing our old products as garbage, and we finally start seeing that 100,000-ton Lego set for what it really is, the permanent building blocks of whatever we choose to build next.